Thomas computer audio gone. Admit all. Got it. All right. -1, 9-2. Good morning, all. Go ahead and throw those screens on, guys.
Morning.
Morning, morning. Do I have a Kirsten? I do not. Alex, no being under the covers. Come on, man. All right. I can't. Where's Dean? Dean's coming in. All right. I got an Alex. He is present. Got a Vinny. I got hi Hickey. Dean is here. Elijah, Corin, Robinson, I do not see. Thomas, I saw her though. Ward, no. And White, and yes, Mr. White. Okay. Boo, boo. And Leah Hall, 9. And Kirsten, not present. Okay. All right. Good morning, all. Good morning. Okay. Hey, you have friends. Who's your friend there, Elijah?
My sister.
So not a friend, just a sister. Okay, I see how it works. There we go. She's just mocking us by eating chips on screen when we can't be eating. Oh, I see how it is. Oh, that's cold, dude. It's cold. All right. Hey, Caleb, Dean, Chloe, if you wouldn't mind, I'd appreciate cameras. Okay, here we go. Let's talk. Today, hi, Caleb. Morning, Dean. All right, goodbye, Dean. Welcome back, Dean. Hi, Chloe. All right, awesome sauce. Here's a story. Alex has already gone to sleep on us. He's like literally, oh, there he is. He's alive. We got a thumbs up. Okay. Not exactly a posture of learning, but that's okay. We'll take it. Okay, with that, let's go ahead and fire up the Algebra 2. Okay, first things first. Did anybody have questions on last night's homework? I see.
Yeah, how mad would you be if I told
you? Just a second. I see no. Dean, what did you say?
How mad would you be if I didn't submit work for 2 of the things because I forgot to
wouldn't be mad at all, but I would totally give you big fat zeros.
Whoa.
Oh, what now? What? You want to bring it?
Whoa.
Oh. All right. Now, the only reason I say this is because if we look on the screen in the giant dotted line box, what do you have to do?
I forgot, okay? I forgot.
Okay, well, here's how you solve that problem. I can help you out, bro. Okay, here's how you solve that problem. For the ones where you plot points, you had to do what? 5 of them or 4 of them or whatever?
5
of them. Here's what you do. You draw a y-axis and an x-axis on a piece of paper, and you pick 5 points, and you plot them and you label them. Okay. Boom! We're done.
So I gotta redo it, kinda, or
just plot 5 points and label them.
But I don't remember what the problems were. That's the thing.
Any 5 points will do. I'm giving you permission to do any 5 points.
Whatever.
Okay. Now the other one, unfortunately, the one where you have to determine whether it's a graph or evaluate the function of a graph. Yes, you will have to go back in and either look at the problems you did, which you can do, or just go in and do like 5 more. Because like literally it's like, is it a function? Yup. Is it a function? Nope. Okay, but I need the graphs. Now, it does sound silly. I get it. I admit it sounds silly to show work for those things, right? However, we're developing good habits because let's be honest, in the last 2 years, would you say that you have been encouraged to develop positive math habits?
No.
Yes and no.
No. Deny. Okay.
You had Miss Smith.
Yeah.
That's what I'm telling you. So what I'm doing is we're like, it's like the army. We're tearing you down to rebuild you stronger and better, okay? And to do that, you got to show work, because even though these are pretty easy, I get it. We're going to get into some tough stuff pretty quick, and I'm going to need to see that work, because if nothing else, guys, this way, when I say, well, which one did you have trouble on, or which ones did you have trouble on? All you got to do is take your camera or your laptop, snap a picture of the ones you had trouble with. I can help you figure out what's going on really quickly. Otherwise, you're emailing me, go, I had trouble on this one. What did it say? I don't know. It was wrong, though. Not awesome helpful, right?
So if we didn't like draw graphs, can we resubmit it? Because I showed work, but I didn't. Okay.
Always. That's the goal of Edpuzzle Delta Math. You can redo and get that 100%. So if you just want to go do a couple extras, just like Dean, even if they're not the problems you did to get the credit, if you just do a couple others, winner, winner, chicken dinner. Okay? So I'm all in. I'm all in on that. But that is why I have the little dotted box that says, because having done this for 20 years, I know it's crazy that teenagers might not show their work, but I did anticipate that. You know, I did anticipate your every move. Math Ninja. Here we go. All right, here we go. So, seriously though, did anybody have any trouble on those? Okay. If you did, how come Kirsten just cannot get in? She is on the struggle bus. Like, she keeps wanting to get admitted. She must have a rough connection. Okay. So let's talk about new stuff today. Notation. So nobody had function troubles. Okay, cool. Then that makes today a little easier. So we're on slide number 5. So let's go to slide number 5. All right. Now, on slide number 5, you will notice attributes and end behavior. Now, ladies and gentlemen, I'm gonna unshare my screen here real quick, and we're gonna talk. I want everybody's eyeballs right here for a minute. Every year, every student that we do this section on makes this section way too hard. There is nothing hard here. Are you ready? If I have a graph and it looks like this, the point here at the top is called the what? Oh dear God, somebody say something. The point at the top.
Goran, say something.
Oh.
Supposed to be just a straight line of a graph, or is it supposed to curve or something?
Here, how about this? Maybe we'll do this. How about this? This is a graph. What is this point right here? The one at the top.
The highest?
Close. What's another word for the highest point on a graph?
Top.
I think he's sandbagging us all today.
No,
Maximum. It's the maximum value. Why? Because it's the biggest. So, white, going to you, my friend. What is this value right here?
The minimum?
Nailed it. You got it. You got it. Now, here's another question, though. This is this OG PowerPoint that I got going on here. All right. Is this point a maximum as well?
No.
Yes, it is. It is a maximum as well. But listen, we have two different names. Absolute max, because it's absolutely the tallest. Relative max, because it's relatively tall. Does anybody notice in math when we name things, we're the least creative naming things ever? Like when you add segments in geometry, we call it the segment addition postulate. Right. When we call it alternate exterior angles, what do you think that theorem has to do with?
Alternate angles are on the outside.
Yep. you nailed her. Okay, so absolute max, highest ever. Relative max, absolute ever. Now, here's a trick question. Are you ready? This one actually may tax the Corin. Okay. This point right here, is it an absolute minimum or a relative minimum?
Relative.
Who said that?
Elijah.
Elijah? Why would you say it's a relative minimum?
Because Grace said that it was a relative minimum.
Who's Grace? Oh, your sister?
Yeah.
Good job, Grace. Free points for the day because does this graph go lower than this?
Yes.
Yes, it does. But this is a minimum, isn't it? Now,
Yeah.
here's the next question. Is this point over here a minimum?
It's a minimum, but it's not the maximum because you draw an arrow that shows it goes on forever. So it will keep going lower.
Okay. It's a trick question, isn't it? This is not a minimum because it keeps on going. For this minimum here, the graph came down and went back up, making a minimum, right? This graph here went to the top, then went down, making a maximum. It's only a max or a min if it changes direction. Get the idea, guys? So if it goes down forever and ever and ever, not a minimum because it doesn't ever loop back up. Same thing if it goes up and up forever, it's not a maximum unless it loops over, okay? Another trick question, what about this one that comes down and then just keeps on going? Maximum or minimum or neither? It's just going to go flat
It's
line.
not going up, so it just broke
Neither.
the rule you said where it has to go back up.
That's correct. It's not a maximum. It's not a minimum because it just stays flat. Now, if it were to curve back up, it's a minimum, right? Does that make sense, guys? So, max, min, up, down, like Sesame Street, right? Don't make this section too hard. Just don't. Hi, welcome back, Vinny. Okay, now, let's talk about end behavior. Again, math people and creativity, where do you think you would find the end behavior?
At the end.
That's why he's the genius right there. At the ends. Here's the deal. I can literally fold this paper up. So here's my graph. Transform, form of. Okay. I can literally ignore everything in the middle of that graph because why? Everything inside that's hidden is not the end, correct? So I only care about this much of the graph and that much of the graph for end behavior. So here we go. Now, correct me if I'm wrong. To you, this is maximum, right? This is positive direction. Is this the positive direction on a graph when you view it from your screen?
Yes.
Thank you. Okay.
Yeah.
This is negative. This is positive. Just checking. Okay. So as x goes forever this way, the graph can do one of three things. Are you ready? It can go up, down, or somewhere else. Now, here's why I say that. If I have a parabola, as it goes forever this way, it's going to go up, 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 up. Do we agree? So as x goes to positive infinity, y goes to positive infinity. Over here on this side, as x goes to negative infinity, y goes to positive infinity because it goes up. So as it goes this way, up, this way, up. Okay, on our graph right here, Does it make sense on this side that as x goes forever in the negative direction, it's going down? So we say as x goes to negative infinity, y goes to negative infinity. Over here, why does it make sense that as x goes to positive infinity, y goes to -2?
'Cause
Why
it's a
does that make
straight
sense? Somebody explain it.
It's a straight line, so it
It's a
won't
straight
go
line.
upward.
So it's going to go down to -2 and just stay there, correct? All right. Oof. Now, again, nothing hard about this. So why am I taking so much time on this? Because every single year, pre-calculus, basic algebra, doesn't matter where we do it, kids are still like, I want to make it harder. Just don't. In this case, you can see the little graph, right? As x goes forever positive, y goes -3. As x goes forever negative infinity, because x is going back here, it goes up to +3. Again, why do I not care what's in here?
It's the middle.
That's the middle. Every one of these graphs, you're going to give me 4 answers. You're going to say, as x goes to negative infinity, y goes somewhere. As x goes positive infinity, y goes somewhere. You must write it the way I write it. X, arrow, positive infinity, y, arrow, something. You must write it like that. Now, I know at this point you're like, yes, we get it. Move on. I'm just telling you, every year I'm going to get half dozen emails going, I didn't understand the ends. Okay. Now, let's see here. What time is it? Great. We're good. Let's go and let's talk about the delta math. Okay. In this case, hey, there we go. That's not what I wanted though. Stop that. Go back. Where'd it go? There it is. That's what I wanted. Okay. Okay, what is B? Yell it out. Bryn, what is it? Oh, never mind. Elijah beats to it. B is a maximum. Relative or absolute, Bryn?
Relative.
That's right, because it goes higher over there, even though it's not a maximum. Caleb, D is a what?
Minimum.
What kind of minimum? Absolute or relative?
Relative.
Good job. Okay. What is the end behavior over here, Chloe? End behavior over here. I'm going to give you half of it. As x goes to negative infinity, where is y going?
You mean like, are you asking me if it's going down? Is that what you're
That's
asking?
correct. So it's going down. So if it's going down forever, we would say y is approaching positive infinity, some number, or negative infinity.
Negative infinity.
Love it. Okay. Kirsten, this end. Give me the end behavior over here. As, fill in the blanks, as x goes to
The right.
positive infinity,
Yeah.
y goes to
The left. The negative infinity.
over here where it goes up.
Oh, positive.
Positive infinity. So in this case, positive infinity, positive infinity. Now, in this case, folks, as x goes forever negative infinity, where's y going? Where's y going?
Negative infinity.
Negative infinity. As x goes, because as it goes forever this way, as x goes to positive infinity, y goes where? Down, I heard, which is?
Negative.
Negative infinity. Very good. Is B an absolute max?
Yes.
Yes, it is. Is E an absolute max?
No.
No, it's a what kind of max?
Negative infinity.
Relative, I think. Yeah. Vincent, is that your microphone or is that Dean's? So,
I'm on sheet.
ooh, that's Dean's. That's rough. Okay.
Sheesh.
I'm looking for a trick question. What is A?
Nothing, because it doesn't go back down. It just keeps going up.
That's it. It's like a sled hill, isn't it? It comes down, but then it goes down some more. So it's not a minimum because it doesn't go back up. It's not a maximum because it didn't come up to that point and go down. So it's nothing. If anything, you can call it a plateau point. Okay, so guys, I know this seemed a bit maybe underneath you, okay? But trust me, every year it's a pain. So I think you guys can handle it. You can be the smartest group yet. All right. Any questions on what we've talked about today? Okay. Your homework is slide number 5. I will warn you, tomorrow's going to be a big day with 6 and 7. So if you want to get a head start, that's some big eyes, White. Okay. So if you want to get started on 6 or 7, feel free to do that tonight because that's tomorrow's homework. Additionally, I sent an email out to parents saying, hey, parents, check all the homework because people, I've got the homework all put in the grade book and I'm going to put all new homework in either tomorrow or Friday. So make sure you have it all. Okay, guys, bye.